Continue application of dimensions. I to check the correctness of any physical equation. It is already over. To check the correctness of physical equation, double I to dimensions are used to derive a physical equation. So now we will study to derive a physical equation using dimension. Kinetic energy of a body kinetic energy of a body depends on mass of the body and velocity of the body. If kinetic energy of a body depends on mass of the body and velocity of the body, derive an expression ଆଜ୍ଞା ନା 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 କିଛି ଦରକାର ବିଶେଷ କରିକି ଦେଇଛି ନା ମୁଁ ଖାଇଦେବି ମୁଁ ଦେଇଛି ତ ଖାଇଦେବି ସିଏ ଖାଇଦେବେ derive an expression for kinetic energy. If kinetic energy of a body depends on mass of the body and velocity of the body, derive an expression for kinetic energy. Let kinetic energy is equal velocity of the body is V. Mass of the body is M. According to question, kinetic energy of the body depends on whom? Depends on mass and velocity. According to question, EK means kinetic energy proportionate M mass of the body. But one thing, mass of the body, whether it is square of the mass of the body, cube of the mass of the body, or inverse of the mass of the body, means 1 by m or m square or n cube or root n, silent about it. Only it is stated, it is given that kinetic energy depends on mass of the body, but in which form? Not mentioned. So, EK is proportional to n to the power x. X represents, if it is square of the mass, then it is 2. If it is cube of the mass, then it is 3. If it is inverse of mass, then it is -1. So x will be decided later on. Okay? But we do not know. Suppose simply it depends on mass. No square, no cube, no inverse, no root. No problem. The value of x will come out as 1. So, EK proportional to m to the power x. X value ek is zero. So, EK proportional to m to the power x. In second step, it is being stated that kinetic energy depends on velocity. In this case also, it depends on velocity, not on square of the velocity, cube of the velocity, or velocity inverse, or anything else. Nothing is given. So, EK is proportional to V to the power y. Suppose kinetic energy is depending or depends on simply velocity of the body, no problem. The value of y will be 1. Combining equation I and equation II, we get, combining equation I and equation II, we get E k proportional to n to the power x into v to the power y implies ek is equal to k. K is the proportionality constant. K is the proportionality constant. Ek is proportional to m to the power x into v to the power y. Implies Ek is equal to k into m to the power x into v to the power y. Now we have to find out what is the value of x and what is the value of y through dimensional analysis. Dimensional formula of Ek is equal to m to the power 1 l to the power 2 t to the power minus 2. Dimensional formula of m, simply m, is equal to m to the power 1 l to the power 0 t to the power 0. Dimensional formula of v m0 L1 T minus 1. These are the three-dimensional formula of kinetic energy, mass and velocity. Now हमें कौन पाइछु Ek is equal to k m to the power x into v to the power 1. Now what we have to do, we have to compare the dimensional formula of both LHS and RHS. What is there written in LHS? Ek. What is written in RHS? K into m to the power x v to the power y. What is K? K is a proportionality constant. Means K does not hold any dimensional formula. It is a constant. You can say it is a dimensionless quantity. So K is a proportionality constant. Here it is a dimensionless quantity. Then we have to compare the dimensional formula of Ek with the dimensional formula of m to the power x and e to the power y. So now you just write comparing both the sides, we get m1 L2 t minus 2, okay, is equal to m1 L2 0 t 0 to the power x into m0 L1 t minus 1 to the power y implies m1 L2 t minus 2 is equal to m to the power x 1 into x 0 to x 0 t to the power 0 into x 0 m to the power 0 into y 0 l to the power y t to the power minus y is equal to implies m to the power 1 m to the power 2 t to the power minus 2 is equal to m to the power, here m to the power x into m to the power 0, that means m to the power x plus 0 means m to the power x, or we may write x plus 0, l to the power 0 plus y t to the power 0 minus y, okay. Comparing both the sides, now we have to compare. Here m to the power of m is 1, here the power of m is x plus 0 means x, here the power of l is 2, here the power of l is 0 plus y means y, here the power of t is minus 2, here the power of t is 0 minus y means minus y only. So by comparing both the sides we get x is equal to 1, equation I. The next 0 plus y means y is equal to, here l to the power 2, here it is L to the power y, means the power of L is here 2. In RHS the power of L is y. So comparing both the sides means you have to equate. So now y is equal to 2. Double line. Similarly, here t to the power minus 2, here it is written t to the power minus 1. So comparing both the power of t, we get minus y is equal to minus 2, implies y is equal to 2. This is the third equation. Now, from these three equations, it is clear that the value of x is 1, the value of y is 2. In third equation also, the value of y is 2. That means x is 1, y is 2. Hence, kinetic energy K is equal to K into m to the power x, means m to the power 1, v to the power y, means v to the power 2, k m v square, k m v square is equal to half m v square. Here in SI system, K is equal to half finally we get Ek is equal to half m v square. This is the equation of kinetic energy. Okay, this is the equation of kinetic energy. Ek is equal to half m v square. Now we have to move to another equation. If force of a body depends on mass of the body, comma, radius of the circular path and velocity of the body on the body is F. Mass of the body is M. Velocity of the body is V. Radius of the circular path is R. Here, radius of the circular path is R, which means the body is moving along a circular path. This is the radius of the body. This is the body. The body is moving in a circular track or circular path with velocity. This V is the tangential velocity. Tangential velocity. This velocity is the tangential velocity. Here the velocity of the body is V. When the body is here, the velocity of the body is in the direction, will be in this direction, right? When the body is moving in clockwise direction. When the body is here, at this point, its velocity is tangential. Tangential means tangent. Tangent means sparshaka, right? So this is V. Tangential velocity is V. The tangential velocity of the body is V. Radius of the circular track is R. Mass of the body is M. Now we have to derive an expression. We have to derive an expression for force. Do you know the name of this force? The name of this force is centripetal force, means kendriya bal. Centripetal force means kendriya bal. So now we are going to find the equation of centripetal force. Centripetal force means kendriya bal. Okay, let's start now. The symbols we have used for force is F, for mass is M, for velocity is V, radius of the circular path is R. Earlier I have stated you, symbol is very much important while when we used to interpret it, or we used to derive, or we used to deal with any type of calculation related to physics. So symbol is very important, and these are the symbols we have used. We not only the symbols, we also know the dimensional formula of force, mass, velocity and radius of the circular track. In last question, I have stated you that here it is clearly written the force. If force of a body depends on mass, it is written simply simply mass. It is written simply mass. It is not written whether it is 1 by m or whether it is m square or whether it is m cube or even n. So there is no certainty that it is simply m. It may be m square. It may be 1 by m. That's why we generally use x as the power of m. If it is simply m, then x will be 1. Then the power of the v means velocity, we will take as y, and the power of r we may take as z. Before interpreting the equation, we must have to write their dimensional formulas. First, dimensional formulas, dimensional formula of f. You know the dimensional formula of f, it is m1 L1 P minus 1. Similarly, dimensional formula of m m1 L0 P0. Similarly, dimensional formula of V M0 L1 P minus 1. Okay. Dimensional formula of R. This is radius. Radius is a length. So M0 L1 T0. Check it again. Dimensional formula of F is equal to ma. So mass is here, acceleration is here. Is it here? No, acceleration is not there. So how I came to know acceleration is not there? Because I have written it is L to the power 1 and T to the power minus 1. Why I have written this? Knowingly I have written this. Because whenever you are writing the dimensional formula, you have to check it again. Chances of mistake is there. So you see what I have written here? Force. I have written here force. I have written here force. The formula of force is F is equal to ma. That means mass is there. Mass m. So m is here. M to the power 1. M into a. A means acceleration. What is the dimensional formula of acceleration? L1 t minus 2. But what I have written? L1 t minus 1. Knowingly I have written this. Because unless there is a mistake, you cannot rectify yourself. So mistake should be there, and to rectify a mistake, the procedures we used to follow, that will be helpful while deriving an equation, solving a problem, etc. So now I have to recheck all the dimensional formula again before applying the dimensional formula to derive the equation. So F is equal to Ma, it should be M1 L1 T minus 2 because it is acceleration. The dimensional formula of acceleration is L1 T to the power minus 2. Now, dimensional formula of mass. Here it is only mass. So it is written M1. No length is here. So it is L to the power 0. T. No T is here. No time is here. So it is T to the power 0. It is correct. It is also correct. Now, dimensional formula of V. V is equal to S by T. That means L by T. That means L1 by T1. That means L1 T to the power minus 1. M is not there. Then what must be the dimensional formula of V? The dimensional formula of V is M0 L1 T minus 1. M0 L1 T minus 1. It is correct. Now, dimensional formula of R. R means radius, means length. It is a length. So, no mass is there, no time is there. That means M to the power 0, L to the power 1, T to the power 0. It is also correct. According to the question, what we have to write? According to the question, force depends on what? Force depends on mass. Force depends on radius. Force depends on velocity. Okay? According to question. According to question, F proportionate to M depends mean it is proportionate, right? It is depending upon mass. Okay, it is depending upon mass, so it is M to the power x. Equation I. Similarly, F proportionate to radius R to the power y. We do not know whether it is R or whether it is R square or whether it is RQ or whether it is R to the power minus 1 or R to the power half. We do not know. That's why we have to get R to the power y. Y will come out and y will give you the exact presentation of R in this equation. Okay? F proportionate to V. So write F proportionate to V to the power Z. Combining all three equations, we get combining all the three equations, we get F proportion or F is proportional to m to the power x into r to the power y into v to the power z. One thing I want to tell you, in the first case you have taken m, in the second equation you have taken r, in the third equation you have taken v, and the power of m is x, power of r is y, and power of v is z in systematical way, in accordingly. If I would write here f is proportionate to v, so now I have to write what I have to write, f is proportionate to v to the power y. Then which physical term remains? R. I have to write again f proportionate to r to the power z. So doesn't matter whether it is m to the power x, whether it is r to the power x, whether it is v to the power x, or whether it is m to the power y, r to the power y, v to the power y, or m to the power z, r to the power z, v to the power, doesn't matter. But the power of those physical quantities must not be identical, must be different. That's why in first equation I have taken the power is x, in second equation I am written the power is y, and in the third equation I have taken the power is z. So the change of placing the equation doesn't matter. Now combining all the three equations we get f is proportionate to m to the power x, r to the power y, e to the power z implies f is equal to k, when k is the proportionality constant, m to the power x, r to the power y, and v to the power z. Right? So now we have the equation of force as F is equal to K into m to the power x, r to the power y, v to the power z. आम पाखरे तीनोटी अज्ञात राशि अछि. कौन कौन से गुड़ाक? x, y, z. एमान को इंग्लिश से कौन कहती? वेरिएबल्स, unknown quantities. So now here there are three variables x, y, z. For three variables or three unknown quantities, we have at least three equations. Now comparing the dimensional formula in both the sides, in LHS it is force, in RHS it is m to the power x, r to the power y, v to the power z. Comparing the dimensional formula or the dimensions in both sides, we can able to get three equations. Let's start now. Comparing dimensions in both sides, we get comparing dimensions in both sides, we get, okay, how to get dimensions? We have to write the dimensional formula, then after we will get the dimensions. In left hand side, it is f. So I am writing the dimensional formula of f, m1 l1 t minus 2. Okay, is equal to k into, it is n to the power x, means n to the power 1, l to the power 0, t to the power 0, whole to the power x, into r to the power y, means n to the power 0, l to the power 1, t to the power 0, whole to the power y. The next b to the power z. So now it is n to the power 0, l to the power 1, t to the power minus 1, whole to the power z. Now write it here, f is equal to k m to the power x r to the power y v to the power z. Okay, implies n to the power 1, n to the power 1, t to the power minus 2 is equal to k. Now this is n to the power x, l to the power 0, t to the power 0. Similarly, it is n to the power 0, l to the power y, t to the power 0, and it is n to the power 0, 0 into z 0, l to the power 1 into z, z, t to the power minus z. Okay. Now here is the base is m, here is the base is m, here is the base is m. So calculate now k into, it is simply m to the power x plus 0 plus 0. Sorry. Now it is l to the power 0 plus y plus z. Then t to the power, it is 0 plus 0 minus z. Okay. By comparing both the sides, you see here in LHS it is m to the power 1. In LHS it is m to the power 1. Here it is x. Finally we can write this is equal to m to the power x, l to the power y plus z, t to the power minus z. Okay, So now here n to the power x. That means comparing dimensions in both sides. Dimensions in both sides. First equation, x is equal to 1. So now the first equation is x is equal to 1. This is the first equation. Then dimension of n is 1. Here it is y plus z. So now the second equation is y plus z is equal to 1. This is the second equation. Now here the power is minus 2. Now here the power is minus z. So the third equation is minus z is equal to minus 2 is equal to minus 2 implies z is equal to 2. This is the third equation. From first equation directly we are getting the value of x. From the third equation directly we are getting the value of z. Now we have to find the value of y. So apply the equation, the value of z from equation 3 in equation 2. So write it now. Applying the value of z from applying the value of z applying the value of z from equation third in equation double I we get कौड़ा में पायु we get y plus 2 is equal to 1 implies y is equal to 1 minus 2 implies y is equal to minus 1. So now we came to know what is the value of y. So now we can write the equation easily. Hence f is equal to k into n to the power x. What is the value of x? 1. n to the power 1. R to the power y. So right here r to the power y. What is the value of y? Minus 1. Minus 1. Then it is v to the power z. So write v to the power z. What is the value of z? 2. Clearly you can write this is equal to k m v square m to the power 1 by r to the power 1. Generally we won't write r to the power 1, so it is simply r means r to the power 1, m means m to the power 1. Okay, now the equation came out, f is equal to k mv square by r is equal to simply m v square by r in SI system, International System of Units, K is equal to 1. Okay. Suppose you do not know what is the value of K, so don't write this. If you do not know what is the value of K, you shouldn't write it is mv square by r. You just stop it here. F is equal to K mv square by r. If you know the value of proportionality constant, you are able to remember the value of the proportionality constant, then you just write in SI system K is equal to 1, hence F is equal to mv square by r. Do you know what is this? This is the centripetal force. Kendriya Bada. This is the centripetal force and its equation is F is equal to mv square by r. You have studied it in class 9. Okay, all the best. Meet you in next class.